Hi, this is Tom, and in this video we're going to continue adding rational expressions with unlike denominators. So here's our problem. Simplify x minus 5 over x squared plus x minus 6 plus x plus 1 over 2x squared minus 3x minus 2. So the first thing is these are unlike denominators, so we need to find the LCM, the lowest common multiple, of the denominators. So we need to find the lowest common multiple of the denominators. In order to do that, we're going to have to factor each denominator. And I know we've done this quite a bit, but just to show you the entire process of this problem, we'll do all of the steps. So I play the game. I have a 1 times a negative 6 to get minus 6, and I have a 1 that's in front of the x term. So that looks like plus 3 minus 2. So I rewrite the polynomial, as x squared plus 3x minus 2x minus 6. I factor by grouping. So I take out the common factor in the first group, x times x plus 3 minus a 2. Oh, look, that gives me another x plus 3. So now my greatest common factor is x plus 3. I'm left with x minus 2. Okay, my next denominator is 2x squared minus 3x minus 2. Let's play the game. And it's going to be a 2 times a negative 2 to get a negative 4. Negative 3 goes in the bottom position, and this looks like a negative 4 and a positive 1. So we rewrite. So I have 2x squared minus 4x plus 1x minus 2. So my common factor is a 2x. That's going to be x minus 2. I need to factor something here so that I can create a greatest common factor. So let's factor a 1, and that leaves me an x minus 2. And that works. Now I have a greatest common factor, x minus 2. Take that, factor that out. I'm left with 2x plus 1. Now, to find the lowest common multiple, so look at what we just did. We took x squared plus x minus 6, and we wrote that as x plus 3, x minus 2, and then we took 2x squared minus 3x minus 2, and we wrote that as, an x minus 2. So let's line up our columns. I think it makes this easier to track, times a 2x plus 1. Okay, so it looks like since each of these just appears once, then we'll need one of each factor to create our lowest common multiple. And remember, the lowest common multiple now becomes the lowest common denominator for this problem. So now we have to take each of our beginning fractions and write them with the new LCD down here. Okay, so let's try this. That's my first fraction is x plus 5. Did I get that correct? Yeah. Oops, x minus 5. That's why I check these things. X minus 5 over. Now, I could write x squared plus x minus 6, but I just did all this factoring work, so let's use that, and we'll just write it as x plus 3, x minus 2. And that'll make more sense, because we know we have to multiply it by something, so that our end result has x plus 3, x minus 2, 2x plus 1. And if you leave it in the factor form, well, now it's pretty easy to see that. Let's see what we've got. So you notice here I have an x plus 3, and here's an x plus 3. And I have, here's an x minus 2. Here's an x minus 2. So it looks like what I need is this. I need the 2x plus 1. So let's multiply by 2x plus 1 over 2x plus 1. Now, this is perfectly fine the way it's written, but when you put it all together, you're going to need to remember to put parentheses in. And I would even put parentheses around the x minus 5 so that I remember to distribute both the x and the negative 5. So let's try this now. Now, to distribute, I go x times 2x. That gives me a 2x squared. Then I take an x times a 1. It's going to be plus 1x. And then, so these are orange, we have a negative 5 times a 2x for a minus 10x. And then a negative 5, let's go times the 1 for a minus 5. Okay. Then, if we clean this up, we get 2x squared plus, nope, not plus, because look at for a moment, let's use a different color here. Notice that here my like terms are 1x minus 10x, and so if I combine those, that looks like that's going to be a minus 9x minus 5 over the LCD. I'm just going to write LCD because we know what it is. We've written it very clearly right up here. Okay, there's our first fraction in the new form, having the LCD. So now we take our second fraction, which had x plus 1 in the denominator. So I have x plus 1 over, and let's write this as its factored form of x minus 2, 2x plus 1. I'm going to multiply it by something so that my end result has all of those factors. It has an x plus 3, an x minus 2, and a 2x plus 1. Let's use a, so notice here's an x minus 2, there's an x minus 2, and here I've got a 2x plus 1, and there's a 2x plus 1. So it looks like the missing piece is the x plus 3. This is what I need. So we're going to multiply by x plus 3 over x plus 3. And for safety, let's put parentheses around everything. Now we can distribute. I go x times x to get an x squared. X times 3 to get a plus 3x. Let's grab another color. How about green? Then I go 1 times x, or plus 1x, and then a 1 all the way over here times 3 to get 3. Okay, back to our black pencil. Let's put this all back together. I have x squared plus 4x plus 3 all over the LCD. Okay, now we've made really good progress. Let's just now look at the whole problem. We started with the problem of x minus 5 over x squared plus x minus 6 plus, let me check here, x plus 1. I'm going to need that. X plus 1 over 2x squared minus 3x minus 2. And then we changed their form so that we'd have a lowest common denominator. So we turned it to 2x squared minus 9x minus 5 over the LCD, plus the second fraction turns to x squared plus 4x plus 3 over the LCD. And now we can add all of this up. Remember if this plus right here, if this plus was a minus, you would have to distribute that minus through the entire numerator, a minus 1. But since it's a plus 1, nothing changes. So we're going to move forward. I have 2x squared minus 9x minus 5 plus x squared plus 4x plus 3. And it's all over the same denominator. And now let's see what like terms. Here's a 2x, oops. What do I have? Here's a 2x squared and an x squared. So I can write that as 3x squared. And then, let's see what else I've got here. Here's a minus 9x plus 4x. That would be minus 5x. And then I have a minus 5 plus 3. My last two terms, we can see them down there. Minus 5 and a plus 3. Let's write that as minus 2 over the LCD. Now, you'd like to be done, I suspect, but what you need to remember is that this fraction, can it be reduced? Well, there's one way to check. Can it be reduced? For example, if the answer, I'm going to put this for example, you would, if you had the fraction of 2/4, you would reduce that and finish your problem by writing 1/2. And the 2/4 becomes 1/2 by factoring. You had a 2 times 1 over a 2 times 2. So now what we have to do is we need to check. And we do this by factoring the numerator. The denominator is already factored, so we don't have to redo that. So let's do this. 3x squared minus 5x minus 2. We'll play the game. So we're going to have a 3 times negative 2 in the top position, which is negative 6. And then we'll have a negative 5 in the bottom position. So I think let's go with negative 6 plus 1. Yeah, that'll work. So we write 3x squared minus 6x plus 1x minus 2. Then we factor a 3x, because we're factoring by grouping. This is x minus 2. We need to factor something, even if it's only just a 1 out of the second group. That leaves another x minus 2. Now we have a greatest common factor of x minus 2. Multiply that by the 3x plus 1. So now we can continue this problem down here. So I would write that, I should probably bring my arrow around, is equal to x minus 2 over 3x plus 1. And to see if there's anything we can reduce, I'm going to have to write the LCD out. And the LCD was x plus 3, x minus 2, and 2 times 2x plus 1. And if we look at this, oh, there it is. There's an x minus 2 in the numerator and in the denominator, so it was worth checking. So our final answer is 3x plus 1 over x plus 3 times 2x plus 1. And now we're done. And that is how you add rational expressions with unlike denominators. Thanks for watching.